So, yeah, I'm Anton Bukov, co-founder of 1inch, and here's my presentation, The Art of Aggregation. So I will start from the beginning, since I discovered that a lot of people on this conference, they are not aware of how all these DEXes, decentralized exchanges, appeared and evolved. So, yeah, a short agenda will look like this. We will first talk about Orderbook-based DEXes, which appeared earlier than others. Then we will talk about AMMs. Then we will discuss what is impermanent loss, because there are a lot of rumors regarding this thing, and not many people really understand what it is and how to deal with it. And at the end, we will discuss the aggregation and like how it was changed since 2019. So yeah, in the beginning, so how any exchange happens, the supply should meet the demand at some price where both agrees. And to make this happen, we need someone to be the first to make proposal and someone else to be the counterparty. So those who make the proposals first are called market makers, and those who agrees to these proposals are takers. There are some differences. So makers usually offer their orders at some desired prices, and takers can fill multiple orders of different prices. And there is one more interesting thing, which how we will categorize different exchanges on blockchain is by the data availability. Some of DEXs are fully on-chain and they do not need any extra data from off-chain. And others are off-chain. They need some extra data, like digital signatures or some kind of proof of something. So historically, one of the first DEXs on Ethereum blockchain were like EtherDelta, ZeroX, AirSwap, Oasis, and finally 1inch limiter protocol, which was introduced 1 year ago. So yeah, if you would look at any order book-based DEX, you would see something like this, that there are some offers to buy and offers to sell some currency. For example, it's either DAI or any other ETH you could know. So usually those who want to buy, they offer their offers are lower than market price, and those who are going to sell, their offers are above market price. And in the middle, they meet each other, and takers can fill them easily. So you can also look at this order book like a depth chart to see it like in a maybe more convenient way if you want to compare how much, if there is a higher demand or higher supply. And yeah, the main idea of these order books on blockchain were that the main idea was borrowed from traditional finance, any centralized exchange, any terminal. And what's different about blockchain that first we just borrow it from what we had, and then next huge step which happened with the blockchains, there was AMMs introduced in 2018. Bancor network was the very first AMM concept. Then Uniswap made this concept even better with, I would say, improved formula and more simple implementation. Later, also other projects appeared. Let's discuss them, and I'll explain how they're different. Like whole concept of Bancor network was pretty cool. They had pools of 2 assets, each of one of each was a BNT token, and you could swap any asset to any over this middle asset BNT. But formula they used, it was pretty complex, and it was also involved ability to mint this BNT if it was lack of this amount. But yeah, much simpler solution was introduced by Uniswap, and it got much more traction. Then also balancer pools appeared. You can see they're like multi-dimensional versions of Uniswap pools, and curve appeared. So initially, a Bancor formula was pretty simple, but this formula allowed you to drain pool. You can buy all of the assets, and it will not be able to sell you more. How different is Uniswap is that they came up to a really simple formula, like product of balances, multiplication of balances should be kept constant, or better, a little bit more to earn fees. So when you try to swap something, for example, you want to decrease balance A to C, it can compute how much it would give you back to keep multiplication constant. So if you would look at balances chart, your balances would move at this line. It's usually called invariant. So yeah, and if this formula will also include some 0.3 fee, as Uniswap had, you will see that this invariant will slowly move out of the beginning, so it will earn profit for liquidity providers. Also, if you would look at Uniswap pools, Uniswap version 2 and version 1 and version 2 pools, you can feel like assets in this pool are equilibrated. So it looks like pool is rebalancing amounts of costs of these two assets to the same value. Like in each moment you have same amount of worth of either and of other asset. Like you can put $1,000 of either and DAI, and after like few weeks you will end up to same amounts of either and DAI, but it could be different USD equivalent. It could be higher or lower. This also depends on impermanent loss. Uniswap v3 concept was changed slightly, so it allowed you to put liquidity on some specific ranges, like this. You can see comparison. First is Uniswap version 2 liquidity, which is like equally distributed from 0 to infinity. So each position in Uniswap v3 belongs to some price range. And if we would see on multiple positions of different people in the same pool, they will be efficiently compounded to each other. And from those who swap on this pool, it makes no sense how many users provided liquidity. Was it one user or million of users? It will be computed with the same efficiency, I would say. And Balancer. Balancer project appeared in the beginning of 2020, but that's interesting to know that both Uniswap formula and Balancer formula was invented by Gnosis, Gnosis protocol, Gnosis project. In 2018, they had an article on Medium. Alan Lu wrote blog post where described Uniswap and Balancer formulas that they could be used to make automated market makers. So that's strange that it took 2 years to implement this formula, or maybe to reinvent this formula. But effectively, Balancer pools are multi-dimensional Uniswap pools. So, and formula looks similar. If Uniswap formula is multiplication of balances of two assets should be kept constant, so Balancer formula is multiplication of balances of all assets in powers of their weights should be kept constant. So Uniswap formula is like one of the cases for Balancer formula. It's like generalized. And one more interesting project appeared in 2020 after Balancer. It was Curve. It was almost like Uniswap, but formula was different, and the core idea of this formula was to introduce super small slippage for lower liquidity. Like having the same liquidity in Uniswap and Curve would give you much better exchange rates at Curve. That's because Curve pools assumes that you have stable coins of the same asset, like stable coins of USD, like USDC and USDT and DAI, or maybe stable coins for Ether, like S Ether, Rapid Ether, something else Ether, A Ether, maybe like Aave Ether. And here we came to impermanent loss and what it is. So if you would put your assets in something which is like rebalancing, like Uniswap V2 pool, it's different comparing to if you would have your assets on your wallet, because it's changing amounts. When, for example, if you have Ether with USDC, if Ether is dropping in price, you will have more USDC. If Ether is growing, you will have more USDC, but if Ether is dropping, you will have more Ether. It's like buying for you something which became cheaper. And if these two assets are changing their prices to each other, it's very important. It's not changing to like any other base asset. It's about changing prices of these assets to each other. If it's changed like, for example, 5 times, we can see that it would introduce some kind of loss to your portfolio of 25%. This called impermanent loss because it's impermanent. This means that if prices will return back, the proportions of these two assets to each other will return back, you will have no loss again. So if you would put your liquidity into Uniswap V2 pool or Curve or any else at some price of these assets to each other, if you would extract your liquidity when price is almost the same, you will have no impermanent loss. But providing liquidity to all these AMMs, you're also earning some fees. Sometimes it's 0.1, sometimes it's 0.3 from swap amount. So what you are trying to do here is you hope that you would earn on these fees much more than you would lose on this impermanent loss when you will decide to withdraw your liquidity. So impermanent loss is actually difference between what you could have if you would just store these assets on your wallet and what you have if you store your assets into automatically rebalancing AMM. So having the assets on the wallet will not give you any impermanent loss, but you will also not earn any fees. Being a liquidity provider means earning some trading fees, but also experiencing an impermanent loss if relative prices of these assets when you deposit them were different from prices when you withdraw your liquidity. And it does not matter what difference was in the middle. It's only important what was when you deposited and when you decided to make withdrawal. And here we came to aggregators area. So we pioneered this topic in 2019. We just noticed that all DEXes had different prices, and our very first move on the ETH New York hackathon was to check prices on smart contracts and offer best exchange for user. But after we did this, like it took like 1 hour or 2 hours, we came up to the idea that the more you swap on each AMM, on each DEX, the worse is the rate. It's usually the same for every DEX and every centralized exchange. So the more you swap, you get first better offers and then you will get worse offers. So what if you would do it a bit smarter? So first move was to select better rate, but we came up to the idea that we could split user volume and swap less on each exchange. And swapping less would give you a better rate than on any other separate DEX. And we also can represent this liquidity sources as glasses. each of them have a little bit different price. You can see this wave, cool wave. And DEXes have different liquidity. You can see sizes of these glasses are different. Some liquidity is huge, some is not. So how you would aggregate here? You can select 3 DEXes with the best possible rates and enough liquidity. But the smartest way here would be something like this. So after your aggregated swap, you would almost equilibrate prices on all these DEXes. And this would also make any arbitrage impossible. So if you would swap on any separate DEX, you could potentially introduce arbitrage opportunity. So someone will backrun you and get profits from this. So that's what exactly you lose if you swap on non-aggregator. But now, since 2020, since 2019, conception changed dramatically, and nowadays aggregation in DEXes in atomic environment is a more complex thing. It's about building multi-road from source token to destination token over some middle assets and using multiple different exchanges on each step. So the more amount you swap, the less cost the fees, the huger is this graph. So here you can see that we're here checking the pairs ETH DAI, ETH USDC, then we change DAI and USDC to USDT or different sources. And at the end, we swap USDT to something else, like compounded USDT or anything else. And yeah, now this looks like a max flow problem from mathematical point of view. But since we have some like conflicts that some pools are like multi-assets, and we have to take into account that swapping multiple times on these pools would change prices, and all the DEXes also have different gas costs. This says about their efficiency. So this is like an NP problem, and there is no proven efficient solution to it. So it's always about approaching to the best scenario and finding new heuristics to find the best possible roads. Yeah, that's a very good question. What 1inch do and other aggregators, I suspect so, is finding the best possible road taking gas costs into account. For sure, it makes no sense to build any complex distribution if user is swapping $1,000 on Ether. But the same $1,000 being swapped on Polygon, it makes sense to make like 10 trades or 20 trades, because it's all about gas costs. If you're swapping $1,000 and your transaction costs you $20, I don't believe any routing could improve your pricing. You will just try to lose less on fees. But if you are swapping $1,000 and paying 10 cents, it maybe makes sense to pay 20 cents and get like $10 more or something like this. So the huger are your amount and the less gas fees, the more incredible road we will see. You can play with it on 1inch. We have visualization for routing. So you could put some huge amount, like swap 1 million. And on Ether, you will see not really huge distribution, but on some other networks, you could see like 50 DEXes in one transaction. Yeah. The coolest thing here that everything happens inside one transaction. So it's all is atomic. So this transaction will be, or it will be included into blockchain with successful state, or if exchange rate at the end will not be enough, it will be reverted. So you do not have any middle state you can stack. Yeah, maybe that's why we are not here a lot about aggregators on non-atomic environments. So there are some blockchains who are sharded, for example. And there is also an idea of cross-chain swaps. I heard it multiple times from different projects. I also talked it with some of them who applied to 1-inch grants program. The thing with it that a lot of people, they think that 1-inch, for example, 1-inch on Ethereum do not have any liquidity from other chains or from centralized exchange. The thing here is that we have these professional market makers, we call them PMMs. What they are doing, they're providing quotes to users of Aggregator, and what they do, if some user would use their quote, user would use digital signature of this PMM, and using some limit order protocol will get some cool price. But what would happen under the hood, this PMM, once they will see that user is buying their 10 Ethers or something, they will immediately sell this 10 Ether on Binance or FTX or on Polygon. They will sell it for a better rate. So they are like doing like a pre-arbitrage here. This means that 1-inch have liquidity of these centralized exchanges and of other chains, and it's being bridged by PMMs. And users enjoy here still atomic behavior. So building something which bridges your assets to different chains and swapping it on different chains is something insanely complex, and you could also stuck in some middle state where part of your assets stuck on some bridge or something. But here, like, the main advantage of this approach is atomicity. See, we have atomic transactions. Users can't stuck in any middle state here. There are some pools where you can be still liquidity provider and you can enjoy smaller impermanent loss or no impermanent loss at all. This would happen if you would put liquidity of the same assets into the pool. Like if you're providing liquidity to Curve pool or Uniswap pool of synthetic Ether and Ether. Synthetic Ether sounds like Ether and price is almost the same usually. So if you will have more synthetic Ether and less Ether, or later you will have more Ether and less synthetic Ether, it makes maybe no sense for you. For example, you don't consider this as a risk. You consider S Ether is Ether, no problem. Or maybe it could be 3 assets, S Ether, ST Ether by Lido, and Ether. So people will use your liquidity to swap directly between these assets, but you will have like no impermanent loss. You can think about it. So if you consider that all these assets are reliable and you consider them all as assets, you can have no impermanent loss like this. Yeah, but if you provide liquidity of USDC and Ether, yeah, this automatically means that you are exposed to this impermanent loss. So some liquidity providers who are doing this like on a high level, they also try to hedge this risk. So there are some solutions. I'm not sure they're like already production ready or not. They are trying to let you short impermanent loss or something like this. So potentially you will be able to provide liquidity short impermanent loss. You will not have any exposure to this. Yeah, but it's like also subject for arbitrage, kind of API arbitrage. Yeah. Yeah, the whole magic is that it's still one transaction, and most of the users, they just understand that this all crazy thing happens under the hood, and they are not exposed to feel it. They do not need to perform multiple actions. They do not struggle with it. And moreover, 1-inch can aggregate among some exchanges which appeared like a week ago, and it's just unsafe to use them. If you would give your approve of some asset to this exchange, it's not time proven. I mean, it's like works from previous week. It could be hacked, for example. But when you are using this exchange over 1-inch, you are protected by 1-inch smart contract, because these smart contracts make sure that exchange rate after all these trades is good enough for you. And that's why you are able to access like 80 DEXes on Ethereum. Yeah, we upgrade smart contract time to time. We do not have any upgradability. We do not use upgradability because we believe smart contracts should be immutable. And when we upgrade our smart contract, we push it as an upgrade, like update, like blog post, and users should reapprove, make new approves to new smart contract. Yeah, but our smart contract architecture also involves executor smart contract, it's external smart contract, and a security audits of our main smart contract states that we could have any implementation of this helper smart contract. That's why we can upgrade it every day without any risks. And we can use heavy assembly, unsafe code, anything we want, because main smart contract audit states that it could use any helper smart contract. It does not rely on its security, yeah. And we do not need to upgrade approves or something. Yeah. I would say there are like two different things here. When you swap huge amount, for example, or liquidity of this asset is not enough, you could swap 100% of your value to 95%. But the slippage is, if you would swap and price will change before your swap or during your swap, you could experience additional slippage. And yeah, previously we had like range of settings on front end to allow you like set like 1% is enough for you, or you can handle 2%, or you are swapping stables and want to handle only 0.1% of slippage. Like something would like unexpected change of the price. But now we recently we shipped after slippage feature. We base it on liquidity of the assets and how much they're liquid and trustworthy. We suggest the slippage to users. And moreover, our recent implementations also track slippages on each swap inside without any kind of gas overhead for this. So yeah, we're also trying to improve this as much as possible. Question is good in general regarding proof of stake and censorship. I would say censorship started before switching to proof of stake. Some proof of work pools started to censor transactions. Those transactions who touched some smart contracts which they don't like to touch. And if we would not have proof of stake right now, we could face a larger issue for proof of work, I would say. If more than 50–60% of proof of work pools would decide to ban some protocols, for example, or some wallets, they could also ban blocks and not build on top of blocks which have these transactions. So imagine some pool or some miner included transaction to Tornado Cash, and most of the miners decided not to build new block on top of this block. They would build on top of previous block and they would win. But since we switched it to proof of stake, there is no longest chain rule for this, and rules are different and they can't do it. So even if we will see 90% of all validators would do it, it's not good. But you still can use the services or use these wallets because 10% of validators will include you. And you will just need to wait a bit more than usually. Like someone recently computed then, right now, I don't remember, like 50 or 60% of validators are doing censorship. And in 2 minutes, you have like only 0.2% probability not being included, because blocks appear every 12 seconds, and like tens of percentages are still not doing this. So in general, I think we will see like renaissance of solutions to prevent this from happening. maybe kind of encryption transaction or VDF or something, because it was not an issue in previous years. So no one decided that we need to solve this. Since we faced this kind of issues, it's good that it's still working, and even like few percentages of validators who are brave enough is enough to handle this issue, but it's not how we feel it should be. I think I'm talking about Ethereum engineers and blockchain engineers. So I think since we faced this issue, we will see some solution coming this year or next year, because people are already started discussing this. I'm not really believe in these things for private transactions, because from my point of view, those who use flash bots for sending private transactions is just, it's like misuse of flash bots. If everyone will use flash bots for sending private transactions and all transactions will be private, how MEV would work at all? So I'm afraid at some point flash bots will decide to reveal all the how they call it, packages of transactions or something. I think they could start revealing this, so we will see how arbitrageurs and the MEV are gonna earn, and we can try to compete with each other, and the miners, validators would earn more money on this. So yeah, I mean, it's like misusage of this tool. Could work temporary. No, I believe everything will be much more distributed and diversified. So we will see a lot of interfaces, a lot of protocols. Some protocols will copy each other because they are pretty much open source. And yeah, I also believe that maybe we will see some struggles with the regulations with centralized interfaces like websites. So probably we will see solutions to launch this kind of services locally. So you can have local version of these interfaces, of DEXes, of money markets, of all these things. Probably they will be like a native interfaces in your wallet or something like this, or they will be like half native, semi-native, or something like this. So you will only interact with blockchain, with nodes, and you will have front end like on your own device. Currently, it's used for governance. We're also going to upgrade governance smart contracts pretty soon to give it like more power. And moreover, we have one more protocol in development since end of previous year, and we hope to finish it in the beginning of the next year. And in this protocol, our token of 1 inch would play like a significant role. I would say it's like comparable to SNX token in synthetics or something like this on higher level. We like initially decided to make it like this, but it took a lot of time to build this thing because it's like really innovative. Hope next time I will show a presentation about it. For some roads, we use optimized router like functions, special functions for special routing, like routing over some Uniswap pools. It's made for extra gas efficiency. But in general, for complex road, we use this additional smart contract, which we call Executor, and we pass additional call data to it. Like, yeah, but it's not easy to understand from this call data what's happening because it's pretty much optimized, compressed, and this smart contract is mostly written in assembly. So we did a good job to make this helper smart contract to be as much optimized as possible, and at the same time our main smart contract is like audited to make sure that this helper smart contract makes no sense. Like it could be absolutely broken. In the worst case, transaction will be just reverted.
So you have to pass this call data in the...
Yeah. Regarding the call data, it's a huge issue on layer 2s. If you're aware of Optimism, Arbitrum, and other layer 2s, currently 90% of transaction fees for layer 2s is paying for call data, which is being just bridged or put it on layer 1. So execution is pretty cheap on layer 2. So compression of call data makes sense here. We saw that Arbitrum recently released a solution to compress call data from storage, and we're also gonna ship something similar for all layer 2s. Maybe this tool will be like really convenient and everyone would use it because it will be, MIT open source. All this computation happen off-chain for sure, but at the end it will end up on the execution on chain, and all this call data contains details on how this should be performed, because now it's not possible to know how much you should swap in the middle. So because when you make transaction, you see some amount at the beginning. And in the middle, for example, when you swap to USDC, you don't know how much USDC you would have. You have some number, but it could be changed because of someone could make a swap on this pool before your transaction. Price will be changed, and you don't want some money get stuck in the middle in USDC, or if you will try to spend more, you will revert. So all these things should work like in a dynamic manner, and routing information is passed like heavily optimized, and I would say it's like almost impossible to understand how exactly this data is formed. So users of 1inch, they usually just use 1inch API. For those who want to use it programmatically, they ask API to build some route for them, and this API would produce some call data, which is like a black box currently, That's like other side of all this optimization, that it's hard to understand what it is, but I'm not sure someone need it. Thank you. Moreover, we recently upgraded this executor smart contract. It was like one of the heaviest optimization. We like reduced the extra computations so much that our executor currently is not like doing anything. It's almost doing nothing. If we would compute all the trades, how much gas was spent on trades, and if we would check how much gas was spent by whole executor, the difference will be like really super small comparing to what we had previously. Thank you.